Imagine standing at the edge of existence, a place where the laws of physics crack like thin ice, a region of space where not even light escapes. You are about to cross into a black hole. But this isn't from a distance, not a telescope's eye view. This is first person. What would it feel like to fall inside? What would you see? How long would you survive? Would you even die at all? This isn't science fiction. This is theoretical physics taken to its breathtaking extreme. Buckle up, reality is about to get very weird. Chapter 1. Approach. You're on a one-way trip. Behind you, the stars shine, distant and cold, silent witnesses to your descent. Your breathing is calm but shallow, each inhale echoing inside your helmet like a countdown. The onboard systems hum with a sterile rhythm, but outside, nothing stirs. Your chest tightens not from gravity, but from awe. The vastness ahead is paralyzing, a shadow darker than space itself. Somewhere deep in your mind, instinct screams. Every fiber of your body knows you should not be here, but curiosity overrules fear, and still you drift closer. Ahead, the black hole looms like an open wound in space, a sphere of perfect darkness. It doesn't suck things in like a vacuum cleaner. Instead, its gravity is so strong that space itself falls inward. As you approach, things start to stretch visually and physically. Distant starlight begins to bend. The black hole warps the sky like a lens. Time seems to slow. You feel no pain, no jolt, but the horizon ahead is the point of no return. This is the event horizon. Chapter 2. Crossing the horizon. Here, the laws of physics start to crumble. To a distant observer, you appear frozen in time at the edge, but from your perspective, you keep going. Strangely, you feel normal, the same. You pass the event horizon, and something wild happens. You can now see the entire universe behind you. It's not in front. It's above, behind, smeared across the curve of space. You're falling inward, but the outside is folding over your head. Light from the universe is being bent around the black hole's edge, giving you a final glimpse of everything that was. This is not darkness. It's distortion. Chapter 3. Spaghettification. Closer to the center, gravity stops being gentle. You are pulled headfirst. Your feet feel more gravity than your head. The difference becomes immense. You begin to stretch like spaghetti, your atoms separate. Your body is elongated. Time itself begins to stutter, seconds feel like minutes, and yet the moment seems endless. Reality no longer obeys the clock, not violently, but completely. And yet, you're not in pain. In fact, your brain can't even register what's happening fast enough. You are information now, being drawn into a singular point of infinite density. Chapter 4. Inside the singularity. No science has fully modeled what lies at the core. We call it a singularity, a place where density is infinite and the known laws of the universe collapse. You are no longer falling. There is no direction. Time doesn't move forward or backward. It ceases. And yet, something exists. Are you a pattern now? A ripple of probability? A new beginning? Some physicists believe the singularity connects to other universes' white holes, baby universes, or wormholes. Inside, you are data, your entire history encoded in the fold of space. Chapter 5: Hawking Radiation and Evaporation. You're gone from the visible universe, but the black hole isn't immortal. Hawking radiation slowly leaks mass from the hole, particle by particle. Over trillions of years, it shrinks, fades, disappears. Where do you go? Does your information come back, or is it lost forever? This is the information paradox, and it's one of the biggest unsolved mysteries in science. Some think information is never lost, that you still exist somehow in the echo of quantum fields. Chapter 6: Theories Beyond. Some physicists propose bold ideas. That black holes store information on their surface, like a hologram. That our universe began in a black hole in another dimension. That every black hole births a new universe, slightly different from ours. If true, falling into a black hole is not an ending. It's a transfer. Chapter 7: Perspective. To those left behind, you're gone, vaporized, crushed. But from your viewpoint, time dilates. The universe outside seems to speed up. You could see the birth and death of stars, the end of galaxies. Your fall stretches into eternity. In that way, you become timeless, a ghost in the geometry of space. Chapter 8: Could we visit a black hole? Technically, maybe. Practically, not yet. To survive the tidal forces, you'd need a supermassive black hole millions of times the mass of the Sun. One example is Sagittarius A, the black hole at the center of our galaxy, which has a mass of about 4 million suns. Even more massive is Ton 618, a supermassive black hole in a distant quasar, estimated to be over 60 billion solar masses. In these giants, the gravitational gradient at the event horizon is surprisingly gentle, allowing a hypothetical traveler to cross without immediate destruction, of times the mass of the Sun. In such giants, the gravity gradient is weaker at the event horizon. You could cross it without being torn apart, at least initially. But communication, escape, those are impossible. A journey into a black hole is one way, forever. Chapter 9: Why It Matters. Black holes are nature's stress test. They're not just theoretical curiosities, they're being studied today with real instruments like LIGO, which detects gravitational waves from black hole mergers, and the Event Horizon Telescope, which captured the first direct image of a black hole's shadow in 2019. They break our theories, our equations, our understanding. But they also point the way forward. They teach us that space is not static, that time is not absolute, that reality is deeper, stranger, and more interconnected than we ever imagined. To study them is to study the edge of what's real. Conclusion: the fall never ends. In fiction, black holes are portals of destruction. In reality, they are invitations to confront the limits of understanding. To peer into the abyss is to confront our deepest questions. Where does it all go? what remains of us? And could something stranger than death be waiting on the other side? In science, they're laboratories of truth. We may never truly see inside, but through mathematics, imagination, and quantum theory we can fall. And in that fall, we glimpse the raw machinery of the cosmos.